Introduction to the Northern Lights. The Northern Lights, or Aurora Borealis, are one of nature's most spectacular phenomena, known for their shimmering displays of green, pink, purple, and red lights dancing across the night sky. These lights are a result of interactions between the Earth's magnetic field and charged particles from the Sun. Causes of the Northern Lights. The Northern Lights are caused by solar wind, a stream of charged particles, mostly electrons and protons, emitted by the Sun. When these particles reach Earth, they interact with the planet's magnetic field and atmosphere. The particles collide with gases in the Earth's upper atmosphere, such as oxygen and nitrogen, exciting these atoms and causing them to emit light. The result is the colorful, glowing display seen in the polar regions. The role of the Earth's magnetic field. The Earth's magnetic field plays a crucial role in shaping the Northern Lights. It channels the charged particles from the solar wind towards the polar regions, where they enter the atmosphere. The interaction of these particles with the Earth's magnetic field causes them to spiral along the magnetic field lines, creating the dynamic light displays seen in auroras. Colors of the Northern Lights. The colors of the Northern Lights depend on the type of gas involved and the altitude at which the collisions occur. Oxygen at higher altitudes, above 200 miles, produces red and green hues, while nitrogen produces purples and pinks. The specific colors and patterns can vary based on the intensity of the solar wind and the composition of the atmosphere. Best viewing locations. The best places to see the Northern Lights are in high-latitude regions around the Arctic Circle. Countries such as Norway, Sweden, Finland, Iceland, and Canada offer prime viewing opportunities. In the United States, Alaska is a popular location. The lights are most visible during the winter months when the nights are longest and the skies are darkest. Optimal conditions for viewing. To witness the Northern Lights, you need clear, dark skies away from city lights. Light pollution can obscure the display, so finding a remote location with minimal artificial lighting is ideal. Additionally, the lights are best seen during periods of high solar activity, which follows an approximately 11-year cycle of solar storms and sunspots. Aurora forecasts. Various tools and resources can help predict auroral activity. Space weather forecasts, which track solar wind patterns and geomagnetic activity, can provide alerts about the likelihood of seeing the Northern Lights. Websites and apps offer real-time updates and forecasts to assist viewers in planning their aurora watching trips. The Southern Hemisphere counterpart. The Southern Hemisphere counterpart to the Northern Lights is the Aurora Australis, or Southern Lights. This phenomenon occurs around the South Pole and is visible from high-latitude regions such as Antarctica, parts of Australia, and New Zealand. Cultural significance. The Northern Lights have inspired myths and legends throughout history. In Norse mythology, they were believed to be the Bifrost Bridge, connecting Earth to the heavens. Indigenous cultures in the Arctic regions have their own stories and interpretations of these mesmerizing lights. Conclusion. A celestial wonder. The Northern Lights are a captivating natural wonder, caused by the interaction of solar particles with Earth's magnetic field and atmosphere. Viewing these lights requires the right conditions and locations, but their beauty and mystery make them a sought-after spectacle. Understanding the science behind the auroras enhances our appreciation of this extraordinary phenomenon, bridging the gap between natural wonder and celestial science.